Hello Zizis. We are Team 8-Bit and this is our Phase 2 prototype for Union Bank's problem statement 3, tracking of funds for fraud detection. Today, legacy core banking systems evaluate transactions in isolation using tabular ledgers, leaving them blind to spatial frauds. When an anomaly triggers, investigators waste days manually cross-referencing spreadsheets to trace complex multi-hop layering. We built FundTrace AI to collapse that 5-day investigation into 5 minutes. Let's look at the engine powering this. Starting from the left, we built robust data sources in ingestion layer, and we support three pipelines: PASIM CSV files for baseline training, a Kafka consumer for a high throughput raw transaction topics, and securing bank API polar from strict HTTP ingestion. Now let's see our storage and ML pipeline. Ingested data flows into our Neo4j graph database. Simultaneously, our ML pipeline takes over. Depending on the ingestion method, transaction hit our dedicated scoring worker or undergo pure in-memory scoring. These workers evaluates the network features against our model files to detect fraud topologies. Moving forward, the scored threads are pushed into our fast API's backend alert queue. To ensure real-time intelligence, our Stream API pushes these alerts via WebSockets directly to the frontend, bypassing slow HTTP pooling. You can also see our graph and evidence APIs, which power the deep network queries, and our export API, which uses the ReportLab PDF engine for compliance. Finally, finally on the right, our Next.js frontend, secured by Clerk Auth, consumes consumes these APIs to power the bank ingest terminal, the live canvas, and the network lab. This is the architecture. Now let's see the platform live in action. Our landing page features the bank ingestion terminal. We built production ready Kafka pipelines, but for this demo, we have toggled them off to process the PaySim synthetic dataset. Investigators access the platform through a secure enterprise grade authentication gateway. Inside the live canvas, left sidebar streams real-time threats. When we click this 99% risk round-tripping alert, the specific subgraph loads instantly. We replace static spreadsheets with an interactive WebGL graph. Analysts can physically explore the network, while animated red lines exposes the exact cycle of the laundered funds. Our explainable AI translates the risk score into a human readable threat narrative detailing the exact hop count and risk factors. With one click, the system drafts a fully formatted FIU-IND suspicious transaction report. It maps graph data directly into an audit-ready PDF. We also export the raw JSON payload to ensure cryptographic auditability. Navigating back, investigators can instantly switch contexts to other typologies like layering or structuring. Here in network tab, you can find all the fraud clusters, but due to the volume, due to the higher volume of the fraud clusters, we can see the small red dots over there. Using the temporal scrubber at the bottom, an investigator steps through the transaction chronology, visually providing the sequence and velocity of the fund. Here, clicking any node reveals deep intelligence. Here we copy a specific suspect's ID. And now we can just go to network tab and paste it into the network lab. This allows investigators to manually map the blast radius of an. So this is our GitHub repo where you can find all the codes and documentation. Thank you from Team 8-Bit.